Hi students, Mrs. Gifford here. Today we are going to talk about two-dimensional figures for section 1-6. And after this lesson, there's kind of two things you'll be able to do. First of all, you're going to be identify and name polygons. And then secondly, you're going to find perimeter, circumference, and area of two-dimensional figures. Before I go to the next slide, I just want to give you a heads up that this particular lesson is very vocabulary heavy, so if you could just have some patience with me, then you can put these in your vocabulary section. So first of all, as we talked about, the beginning part of this is all about polygons, and polygons are closed figures, okay, with line segments that we call sides, obviously. So over here, side GH, okay. And then the big thing to remember is that the vertex of a polygon is just where two sides meet. And then the chart below shows examples of polygons and not polygons. Notice that they are completely closed by straight sides. No curvy points, like this one that looks like a flag over here. Those curves are what make it not a polygon. Same thing with these other two over here on the right-hand side. Okay. So here's where I said is there's lots of vocabulary, which is typical of geometry. The first one to talk about is a polygon that is concave. Excuse me. It's when you take the sides of a polygon and you extend them so they go past each other. And if there's a point inside the polygon, we call that a concave polygon. So if you look over here on the left-hand side, here's examples. If you extend those side lengths, these points right here in the middle of the polygon that go through the middle of the polygon are what make this concave. The next one are convex. Same thing, you're going to take those lines and extend them. And now notice in this case with the polygon over here, they cross only at the vertices of that particular shape. So there aren't any points of that extended line through the polygon. Excuse me. Next one is n-gon. It's just a certain kind of polygon with that many sides, like hexagon is a 6-sided figure. A decagon is a 10-sided figure, octagon 8. Next line, or the next word, equilateral polygon. If you look at this, you see the prefix equa, meaning equal, and then lateral talks about the sides. So an equilateral polygon is a polygon that has all sides that are congruent. And then the way that we designate that, if we're looking, for example, at a triangle, this is an equilateral triangle. What you'll end up seeing on those shapes is you'll see little marks, and those little marks are telling me that all three of those sides are exactly the same. In addition to having an equilateral polygon, you can also have an equiangular, equa meaning equal, and angular. So the same thing in this one. Did a pretty good job of it, but you'll see little marks inside angles. And if you see the same curved mark inside each of the angles, that's also telling you that it's equiangular. If you see one, you might see a diagram like this where these two have the little curve and then the third one has two lines. That's telling you that those two lower ones are the same angle and then the upper one is completely different. And then the last two terms, a regular polygon is a convex polygon, so it's like this one here. Excuse me. And not only is it convex, but it's equilateral and equiangular. So actually, this triangle would be considered a regular polygon, and it's because it has equilateral sides and equiangular. And then the last but not least here is that an irregular polygon is one that's not regular. And again, in order for it to be regular, it needs to be convex, equilateral, and equiangular. So all three things have to be true. Otherwise, it's irregular. All right, so let's take a look at some examples. We're going to name each polygon by its number of sides and then classify it as convex or concave and regular or irregular. So there's three things that we're going to do. So in here we have the star, and if you count the sides on the star, there's 2 on each arm, so it's a 10-sided figure. And a 10-sided figure is called a what? It's called a decagon. If you think of a decathlon, Okay, somebody's doing 10 events. So from here, that's the first thing, so we named it. Secondly, we need to name it as convex or concave. And if you look at this closely, and if you actually just extend even one of those arms of the star, you see that the points right here are in the middle of the shape. So we call this concave. Whoa, weird. Not really sure why that happened. All right, so we call that concave. And then the last one is regular or irregular. Now, even though this is showing us that the angles are the same and all the sides are the same, this is irregular because it's a concave polygon, so irregular. Ooh, this is bad handwriting today, sorry. The one above it says concave. All right, so let's go to example B. So again, the first thing that we're going to do is decide what type of shape this is. And as we look at it, it has 1, 2, 3, 4, 5, 6 sides, and a 6-sided figure is a hexagon. Okay. And then we take a look next to decide is it concave or convex. Well, if we look at it and extend all of those sides, none of them are going to cross in the interior of the shape, so we call this a convex polygon. And if you look at the angles, they all have one singular little curve, so we know it's equiangular. And then each of the sides has this one little dash mark, so it's also equilateral. So we call this a regular polygon. And again, in order for it to be regular, it has to be convex, equilateral, and equiangular. Excuse me. So let's switch gears. Let's just do a quick review of perimeter, circumference, and area. Again, perimeter and circumference are basically the same thing of a circle. Okay, so here you see all of the formulas for perimeter. And then this next row are all the formulas for area. The big thing to remember for the area of a triangle is that the base and the height have to be perpendicular to each other. And then again for pi, or for a circle, it's pi times radius squared. And again, we'll use 3.14 for pi. So let's take a look at this example. We have a triangle. We need to do two things. One, we need to find the perimeter, and two, we need to find the area. So perimeter equals 9.5 plus 10.2 plus 9.5. Well, 9.5 and 9.5 is 18, 19, and 19 plus 10.2 is 29.2, and our label is inches. Okay, and now we need to find the area of this triangle. So area is 1/2 the base times the height. So we're going to do 1/2, the base is 10.2 times 8. Well, I would do 1/2 times 8, which is 4, and then I would do 4 times 10.2, which is 40.8. And again, our label is inches, and because it's area, we need to do inches squared. So anytime you deal with area, your label is always whatever the label is with the squared. And if you're just talking about perimeter, then you just keep that label the same. Okay, last example, we're going to take a look at this triangle, and we're going to find both the perimeter and the area of triangle PQR. And notice this is on a coordinate grid, so in order for us to find the perimeter, we need to know the lengths or the distance between each of those vertices. And so we need to use the distance formula for two of those three sides. First of all, side QR is right across here along the bottom. So what's that distance? That distance is 7. So that's the easiest of the three sides. And now if we want to find PQ, okay, we're going to use the distance formula. So we're going to do the square root of, and I'm just going to pick one of those points to be my x2. So I'm going to do -3 minus -1 squared plus, then I've got -1 minus 3 squared. We need to do what's inside the parentheses first. Subtracting a negative is adding the opposite. the square root of, so negative 3 plus 1 is negative 2, plus negative 1 minus 3 is negative 4, and we're going to square them. Negative 2 squared is 4, plus negative 4 squared is 16. So we get the square root of 20. And so we're going to figure out what that decimal is, and we're going to round to the nearest hundredth. So the square root of 20 equals 4.47. Okay, again, that's side PQ. So now we're going to do the same thing for side PR. Okay, so then I've got 3, oops, I'm doing the y's first, I guess I can keep it the same, keep it consistent. So I've got my x's, so I've got negative 1 minus 4 squared plus 3 minus negative 1 squared. Again, do what's inside the parentheses. Negative 1 minus 4 is negative 5 squared plus 3 minus negative 1 is 4. Negative 5 squared is 25 plus 16, and add those together, we get the square root of 41. And again, let's type that in to see what the decimal equivalent is. So square root of 41, I get 6.40, so we've got 6.4. Now, what we need to do to find that perimeter then is take our 7 plus our 4.47 and our 6.4 and add those three numbers together. So 7 plus 4.47 plus 6.4. So our perimeter of triangle PQR is approximately 17.87, and we can just say U for units. Okay, that's for perimeter. Now we need to find the area. Again, area of a triangle is 1/2 the base times the height, and the base and the height of a triangle need to be perpendicular. So as we look at it, we already know that the length of the base is 7, and the height is 1, 2, 3, 4. So we have 1/2 times 7 times 4, and I would do half of 4 is 2. 7 times 2 is 14. So the area of that triangle is 14 square units. So there you have it. We've figured out how to classify polygons as well as a quick review on area and perimeter.